This video is on the distance formula. As you saw in the Unit 2 investigation, the distance formula is based on the Pythagorean theorem. The Pythagorean theorem says that in a right triangle, the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. So for example, in this triangle below, A and B represent the lengths of the legs and C is the length of the hypotenuse. So we have A squared, the length of this leg, plus B squared, the length of this leg, squared, equals C squared. Given a segment on the coordinate plane that is neither vertical nor horizontal, we can draw a right triangle in which the segment is the hypotenuse. So let's take a look at this picture right here. So here we have segment AB, which is a slanted segment. It's not horizontal or vertical. If we need to find the length of a horizontal or a vertical segment on the coordinate plane, we just count. But we make this segment the hypotenuse of a right triangle. So I've drawn a vertical line here and a horizontal line here to make that right triangle. I can calculate the lengths of the legs by taking the absolute value of the differences of their x and y coordinates. So in other words, the length of this horizontal segment here is going to be x2, which is the x coordinate of B, minus x1. X goes in this direction, so if I subtract those and take the absolute value, I'll get the length of that segment. I'm going to do the same thing in the vertical direction here to find the length of this leg, which is going to be the difference between the y coordinates of the 2 points, and I take the absolute value to make sure it's positive. We can then plug those lengths into the Pythagorean theorem. So it looks a little clunky here, but I have the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 squared equals the length of AB, which is my hypotenuse, squared. Notice that we really don't, at this point, don't really need the absolute value bars to make it positive, because when we square that difference, it's going to give me a positive number. So getting rid of those absolute value bars gives me x2 minus x1 squared plus y2 minus y1 squared equals AB squared. Or taking the square root of each side, AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And actually, this kind of is how we more formally write the distance formula. Notice we use the letter D, which represents the distance between the points x1, y1 and x2, y2. So let's take a look. Let's take a look at an example here. We need to find the distance between the points -1, 3 and -5, 9 using the distance formula. So I'm going to say the distance is equal to the square root of, and if you need to label these, you can do this, x1, y1, x2, y2, and I'm going to do -5 minus a -1 squared plus 9 minus 3 squared, and take the square root of the whole thing. That's going to give me the square root of -4 squared plus 6 squared, which is equal to the square root of 16 plus 36, which is equal to the square root of 52, which is approximately 7.2, or if I want to simplify that radical, that's going to give me 2 square root of 13. So in this video, we took a look at the distance formula and how it's related to, or actually more specifically derived from, the Pythagorean theorem.